we're going to talk about equations of circles. So those are the two basic equations of circles. The first one on the left is where the center is at the origin, and the one on the right is when the center is shifted. So when we think about this, x is always married to h, y is always married to k. All right, so x is going to move you left and right, y is going to move you up and down. So h will move you left or right, k will move you up or down. Right? And then in the formula, r is always squared. So basically, it says write the standard form of the equation of each circle described and graph the equation. In the very first one, since it's centered at the origin, we will use this formula. So really, we just have to look at the radius being 9, right? So that's just going to be x squared plus y squared is equal to 9 squared, which then you're just going to say is equal to 81, right? It says and then graph it. Well, we'll graph the next one because this one's a little bit simplistic to graph. But I'll just do this one. So it says that you're at the origin. So I'll say this is 9. I'll say this is negative 9. I'll say that this is 9, and I'll say that this is negative 9. Right? So basically, plot 4 points at those locations, and then do your best to draw a circular shape on your paper. So, one like that that's so basic. You can set your scale, right? So for those when it's at the origin, I just set up my scale how I wanted to. As long as it's labeled, your scale is present, right? So now we want to look at number 7. So with 7, we want to do, okay, this is h, this is k. It's tangent to x equals 3. I'm going to have to draw this. So probably my best move is going to be just to use a graph for this one. So I'm going to put my center on my graph. So I'm going to draw an x and y axis, and I'm going to put my center of negative 1, 4 on my graph. So left 1, up 4, 1, 2, 3, 4. And then it said it was tangent to some line, right? Tangent to x equals 3. Well, I'm just going to draw that dashed, just because I really don't, I'm just going to use it to make this circle. At this point, I can see, well, this is going to be my radius, correct? So how long is that radius? 4, isn't it? So I can tell right here that my r is going to equal 4. And I know where the center is, so using graph paper here is very handy. But if you didn't want to use graph paper, you could say, well, my center was what? A negative 1, 4, correct? And the line x equals 3, so here x equals negative 1, right? And plus 4 gets me to 3, correct? So that has to be my radius. If you think about horizontal distance, right? That's an easy way to get it to. But our formula should be x plus 1 squared, that should be a plus, and then y, what, minus 4 squared, and then equal to 4 squared, which was, what, 16? Always a plus in between the parentheses. Graphing the equation, I would just be 4 to the east, I would be 4 to the west. That would be 4 north. That would be 4 south. Then I would draw my circle, right? So these next couple examples, we are going to complete the square partially to build these squares of the binomial. Notice how it's x plus 1 to the quantity squared. That's a binomial square, okay? Notice that it's y minus 4 to the quantity squared. That's a binomial square. So if they don't give us those binomial squares, then we have to complete the square to build them. Okay, so this is like from chapter 4. Now, number 8. They want us to write it in standard form. This is a general form. Okay, because it's just got what I call alphabet soup down there. So we're going to say x squared needs to be paired up with the 4x. Then we're going to leave a blank. And then y squared needs to be paired up with the 14y. And then we're going to leave a blank. And then we're going to move the 47 to the right. And then we need to put down 2 blanks to find balance. Now, we just want to look at the x terms right now. We want to take half of the middle term, right? What's half of 4? 2. So then we're going to square it. So what is 2 squared equal to? 4. So then 4 goes over here. What's half of 14? We're going to square it. What's 7 squared? 49. So now basically, we're going to take the key components to make our binomial squared. Remember, this is just x squared minus 4x plus 4, right? That's all that is. So that's a perfect square trinomial, so I can write it as the square of a binomial. Then I'll put down my plus, and then y plus 7 squared, because again, I'm using the y, I'm using the middle sign, I'm using the 7. But again, this is y squared plus 14y plus 49. Again, I'm creating a perfect square. 7 plus 7 is 14, but 7 times 7 is 49, right? So I'm creating that perfect square condition. And what's all that add up to be? 100. We're keeping it what? No. So now, what's the center? The center is 2, negative 7. And what's the radius? 10, right? Well, we're not going to graph that because that's going to be too big, but you would plot your point at negative 2, 2, negative 7, and then you would give a radius of 10 all the way around. So let's try 9. Now you got to get rid of the 2's. You can't complete the square. So if you divide every term up there by 2, Isn't every one of them even? You could have done that before I did this one, right? You could have divided everything by 2 and then split. So this is basically going to become x squared minus 10x plus blank plus y squared plus 4y plus blank equals a negative 17 plus blank plus blank. So what's happened to 10? So 5 squared goes here. What goes on the other side? 25. And what's half of 4? 2 squared on this side. What do we put on the other side? So now this becomes x minus 5 squared plus y plus 2 squared equals 29 minus 17, 12. So I need to know my center. Would be 5, negative 2. And I need to know my radius. Is that going to be 2 root 3? But I need squiggle, squiggle, right? Because I can't graph 2 root 3. I don't know how to do that. I need a decimal to the nearest 10. So what is square root of 12 as a decimal? 3.5. I can graph that, right? So anytime they give you something weird for the radius, convert it to a decimal for graphing purposes. So need a graph. So we're going to put 5, negative 2. And then we're going to go 3.5 north, south, east, and west, right? And I try to do it, but it's hard for me. So with circles, it's pretty cut and dried, right? You have a center, you have a radius, and you need to find them. Okay. So now we're going to go to ellipses. Ellipses, you need to look at the picture I gave you. Friday in the notes. Look at the one I gave you Friday. But before we leave circles, I want to say you need to be able to recognize them by the equation itself. Okay. Now, what's the bottom line on the circles telling you? How do you recognize it? What's it say? Is it the third bullet? Certain equations have 2 positive squares with the same coefficients, right? So that's what tells us, like here, this is x squared, this is y squared. They're both positive, their coefficients are both 1, right? Okay, this is 2x squared, this is 2y squared, they're both positive, their coefficients are both 2. Right away, I know it's a circle without doing any work at all. Okay? So organizing it in general form, if you organize it in general form, you can tell. Now let's look at ellipses. What's it say on the last bullet on the ellipse? Oh, I got it. I'm ahead of myself. We can't do ellipses yet. I got it. I'm not going to actually do these. I'm just going to sort of walk you through how to find the general information, and then you can go. Okay, so they want us to write the equation of a circle that satisfies the conditions, right? It tells us a circle passes through this point here and has a center here. You can do that one of two ways. You can graph them, and you can find the distance using the Pythagorean theorem, or you can just find the distance using the distance. So basically, if you think about this, it's telling me that I'm passing through point 1, 5. And the center is negative 2, 1. So basically, I need to find that radius, don't I? Because I know the center, so as long as I know the radius, I can get it. So, this is going to be 3, we would square it. This is going to be 4, we would square it. This would be what? 5, and we would square it, wouldn't we? So you can do that and find it that. You can also do the distance formula. Right? But if we see here from this x, to get from 1 to negative 2, we're moving 3 and we got to square it. Okay, then we see to get from 5 to 1, we got to move 4, don't we? And then we have to square it, correct? So that's still going to be 25, but you will still square rooting at 5. So sort of start visualizing your points and their location and how far the components are apart from each other, just like we did when we did vectors, right? Same stuff. Okay, so but basically this would be R, and I know my center, so I can write that equation. I know HK, I know R, I can write the equation. Now, in the next one, they give you the endpoints. Yeah. Here they give you this endpoint and this endpoint, right? So where's the center going to be? In the middle. So look at both x's. What's the average of the two x values? Negative 2 plus 10, right? It's going to give you what, 8? So the average of that's going to be 4, correct? What's the average of the 6 and the negative 10? Be negative 2, shouldn't it? Don't waste your time writing a formula for something that you can just obviously do. Now, the formula is better like if they're at decimal locations, right? But you can normally find the middle of something, right? Without being too crazy. So now we know this is the center. So now, if I know that's the center, I can use this with either point to find the radius, just like I did, or I can do the distance on the two endpoints and divide it by 2, right? Because if the endpoints are on the diameter and I find the diameter, I divide it by 2, I got the radius, don't I? So there's many different ways you can do that part. But again, once you got the center and once you got the radius, you're good to go. All right. Now to ellipses. So with ellipses, we have one center, 2 foci, and 4 vertices. And you have the picture on your paper to show you that, right? So there's basically like 7 key points. Okay. Now, the 2 formulas we're going to use for this going to be x squared over a squared plus y squared over b squared equals 1. Or we're going to use x minus h squared over a squared plus y minus k 20 squared over b squared equals 1. So one will have the center at the origin, the other will have the shifts like before, right? So depending on which one you know, like automatically your center on the left one is 0, 0. You don't have to do any more, right? But then you always do opposite h, opposite k to find it when it's out. Now, A is telling you how far you're moving left and right if it's underneath X. Okay. B is telling you how far you're moving up and down, and that's from the center. Okay. So A is going to move you left or right from the center. B is going to move you up or down from the center. Okay. Normally, the largest value, they call it A. So in other words, you just are going to have to do some subtraction in this. Always subtract the bigger one minus the smaller one. Then you don't have to worry about it. Now, your foci are going to be discovered using that C formula. So it says here C squared is equal to A squared minus B squared. Now A squared is just going to be the largest term. Okay. And then C is going to equal plus or minus the square root of A squared minus B squared. So that's just the formula that you use. Now, it looks a little bit like Pythagorean theorem, but it's not. Okay? It's developed the same way, but it's still not the Pythagorean theorem. So just keep that in mind. But C, how do we use that? You have two axes. You have a major, you have a minor. Okay? Your center is going to be where they cross. Your foci, think of the foci like the Earth. Okay? Well, the sun's the foci. Think of the Earth as like one of them four vertices rotating around the sun, right? So you want to think of it like that. So basically, the longest axis is your major axis. So basically, the distance from the center to the foci is that C. Okay, so you'll end up having something up here. You'll end up having something down here. You'll have two of them. Okay, and if you can imagine planetary motion, right? Is elliptical, isn't it? You can imagine that. Now they want us to write this equation of the ellipse graphed up here. So let me back off some stuff here. That's in the way. So now we need to find the middle of this. Okay, so what is that point there when you look at yours on your paper? Just eye it. What is that point going to be? What's the center between -10 and -4? -7, right? So your center is going to be -7, 0, correct? Now, how far does it take to get from the center to this point right here? How many spaces are you moving? You're moving 3, right? So you're moving 3 this way. Aren't you moving 3 this way? So left and right, you're moving 3, correct? So basically, x plus 7 squared over 3 squared, correct? Because you're moving left 3, you're moving right 3. Put your plus. Is your y moving at all? No, it's right there on the x-axis, so it's just going to be y squared because there's no shift. But how far are you moving up? And how far are you moving down? You're moving 6, right? So this is going to be 6 squared, and it always equals what? 1. Now, instead of 3 squared, what do we write? 9. Instead of 6 squared, what do we write? 36. So when we are looking at this, we're saying, fine, that this is 9. And that this is 36. I've just wrote the equation of the thing in standard form. Now it says find the coordinates of its foci. Well, they're listed. Oh, the foci, I'm sorry. Vertices are listed. So now I have to do what? 36 minus 9, right? What is 36 minus? Square root 27. Just give me a test. Right now, we're doing c squared is equal to a squared minus b squared. So we're doing c squared is equal to 36 minus 9. So that's 27, correct? So then c is going to equal plus or minus square root of 27, which is equal to plus or minus 3 root 3 squiggle squiggle. So what is that? 5.2? Fine. So you imagine you're going to be on the major axis, which is vertical, and you're going to count from the center up 5.2 and down 5.2. And that's the location of your foci. So my foci, if I can imagine them, are going to be like right here and right here, correct? Because it's not 6, but it's almost 2, 6, correct? Now they want to know the coordinates. Did anything happen to the x? The x is still what? -7, right? But then we got to say plus or minus what? 3 root 3. Because it went from, do you want to say 0 plus 3 root 3 or 0 minus 3 root 3? No. Because you're really just going up 3 root 3 or down. How much is that? Well, it's about 5.2. How many coordinates did I just write? I just wrote 2, didn't I? One with a plus, one with a minus. Keep that in mind. Let's do number 7. For 7, we're going to just do it on graph paper first. We're going to draw the picture and then write all of our information from the picture that we use. Now, which number is bigger on bottom? So that means it's going to stretch horizontally. So that means the foci will be on the horizontal axis. Okay? The one we just did was stretched vertically, right? So the foci were on the vertical axis. Now, technically, whichever one's the biggest number at the bottom is A. I just don't rewrite that, I just realize that. So it's bigger number minus smaller number. And then you have to worry about it. So I'm going to say that 7 is x squared over what squared? 6 squared. I'm going to say that y squared over what? 2 squared, right? Now, where's my center? My center's at 0, 0, right? Because there's no shift. So how many spaces do I gotta count left or right? 6, correct? So I'm going to say a 5. So I'm going to say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, now what are those two ordered pairs? Bottom and then write what they are. What are they? X should go first, right? Y should go second. 6, 0, and negative 6, 0. Now, how far am I counting up and down? Up, 2, down, 2. Write them down. What are those? 0, 2, 0, negative 2. Does anybody care the order you put those in? Nobody cares. You have 4 of them though, don't you? So a squared minus b squared is going to be 36 minus 4, right? Which is 32. So then c is going to equal plus or minus square root of 32. So what is that as a simplified radical, right? And then what is it as a decimal? So root 32 should be what, 4 root 2? And then square root of 32 is going to be somewhere between 5 and 6, right? 25 is 5 squared, 36 is 6 squared, so 32 is going to be somewhere between the what is the decimal? You said 5.7? So that means I'm going to be real close, right? Real close there, aren't I? Now, did the y value change on those foci? So it's just going to be plus or minus, what is that, 4 root 2? And then 0, correct? How many points did I just list up there? So I got all 7 points, don't I? Okay. So always draw your picture. So again, you can imagine, okay, in here is the sun. And then this is like the earth, right? It's kicking it around the So let's do one where we got to complete the square. Let's do number 9. So this is, we can't just divide by 2, can we? So here we're going to have to get creative when you do our complete the square and do some factoring. So how do I know it's an ellipse in the first place? So 2 positive and different coefficients, right? So there's 2 positive square terms, different coefficients. It's an ellipse, not a circle. I almost said not a square. Okay. What can we factor out of the first 2 terms? What's a GCF? 25, right? So 25 parentheses x squared plus 4x plus blank plus, what can we factor out of the next one? Now, it always has to be the coefficient on the square, right? You can't complete the square unless the coefficient on the square term is 1, so it always is just that number you don't have to guess. what's half of 4? 2 and square it. Now, before we add it to the other side, we got to multiply it by this 25 that's just hanging out here. There's the trick. So what is 4 times 25? Keep it at what? Okay. Now, divide 2 by 2, we get what? 1, we square it. 1 times 9? 9. Okay. So now we have to sort of write it out all pretty. So you can't throw away the 25 yet. Remember the x, the plus, the 2. Remember the y, the minus the 1. Equals the whole bunch. How much is that? 225. What's the number have to be on the right-hand side? You don't have to think about what you got to divide by. What do you got to divide by? 225. You don't have a choice. Okay. How many quarters in $2.25? 9. Think about it. That's 220. That's 25. That's 225. Think about it. Think of it like it's money. So x plus 2, the quantity squared over 9, correct? So that means this must be y minus 1 squared over 25 equals 4, correct? Now, what's 9 written as the square? It's going to be 3 squared, correct? What's 25 written as the square? It's going to be 5 squared. So I know I'm going left and right, 3. I know I'm going up and down. Where's my center? Right. I know my center is, well, that's not C, I'll say center. I know my center is -2, 1, correct? So I just put that on my paper. Then I got to count blocks. Okay. Again, I'm counting left what? 3. I'm counting right 3. I'm counting up 5. I'm counting down 5. Correct? So now I can just write down those ordered pairs because they're saying what are they, right? Well, now that I've written down, I should be able to tell what they are. What's that? 1, 1. -5, 1. -2, -4. -2, 6. Check those and tell me if I'm right on them. Do you agree? Now, are the foci going to be on the X or on the Y? On the Y, because the Y is bigger, right? So what's 25 minus 9? 16, square root of 16. So C is going to be equal to plus or minus 4. So that means I'm going to count from the center. 1, 2, 3, 4 up. 1, 2, 3, 4 down. And so we can say the foci are at what, a -2? And then it's 1 plus or minus 4. Now, can you do 1 plus or minus 4? Yeah, you can. What's 1 plus 4? 5. Then 1 minus 4. Is that their location? Yeah, if you do that for me, I'll be fine with it. Okay, but you could say -2, 5. You can say -2, -3. Because you can simplify that pretty easily. How many points total do I have? Got 7, don't I? Now, what did we need when we did circles? Didn't need no 7 points, did we? We needed the center, we needed the radius. But here, you gotta just list a lot of different information. You get to complete the square and be able to read the graph that you're given. Remember, a squared is always the biggest number underneath one of these brackets. I think that's it. I think that's all we need. Yeah, because 8 and 10 are just redundant of what we just did. So I'm gonna stop, and then if you need to finish your test and stuff like that, let me know.